Defense in depth. In this nugget, you and I get to do something amazing, and that is, first of all, identifying what risk is to a company from their perspective, and then, in measurable terms, identify how using the techniques that we have learned together in this series can actually reduce that risk by putting the appropriate countermeasure in place way before the attack shows up. I'm excited about this video. Let's jump in. Defense in depth is something that you and I do all the time. I want you to imagine that we're driving back to a house. We're going to pull in the garage. We shut the garage door. Now it's shut. And then we're going to go in the house. Now if we go in the house, there's also a little door, a human door, to go from the garage into the house. Are we going to lock that door at night, even though the big garage door is closed? And the answer is very likely yes in most parts of the world. Why is that? Because we want to have multiple layers of defense, not just the big garage door, which maybe could be forced open or broken into, but we also want to stop the individual before they come in the house. Multiple layers of defense. That's what defense in depth is all about. So in our practical application of this in a network is we have this beautiful firewall. Maybe it's an ASA. And on that ASA, the attitude of the ASA is to say, no traffic is allowed in from the outside. And we know that because the outside interface very likely has a security level of 0, and the inside maybe has a security level of 100. Traffic going from lower to higher isn't allowed by default. So how do we overcome that? We set up an access list. And the access list says, okay, we want to allow port 80 in, and let me use the color we can see here. We want to allow port 80, and maybe allow port 443, and maybe allow port 25 for email, all to come in so that people can get to these resources, our DMZ servers, the web server and the email server and so forth. If we do that on the firewall, do we really need to do that on R1 as well? To block all traffic inbound except for 25, 443, and 80? And the answer is, yeah, we should. Because that would be a second layer of defense. If something happened at the firewall where it was misconfigured or accidentally all the ports were opened, we don't want to just let the whole world rush in at our gear. Because the port scans that are being done all the time are going to find out what open ports, and if the firewall's no longer there and the R1's not defending, it's going to be a breach. So we want to make sure we have defense in depth every step along the way. So what is the whole purpose of these networks that we have? It's usually to drive revenue. At the end of the day, except for some government entities, they have reasons to protect the state. But for most businesses, we have networks that generate revenue, or they provide a vehicle that assists companies in generating revenue. So if the network goes down, there's usually a cost involved. And if the company is holding sensitive information, proprietary secrets known only to that company, or they have sensitive information that would harm the company if it was released, or if the company's holding your and my credit card information or our social security numbers, they're responsible to keep that safe. If they lost it, what would it cost that company? And in the face of the public, as far as fines and lawsuits and everything else, it boils down to revenue for most companies. So risk, as we take a look at risk, and I did a little research on this, I thought, wow, there's like a whole bunch of different people that all disagree on what these terms are. So I boiled it down into what I think is a nice, easy, tidy package. Risk, right here, is a threat successfully exploiting a vulnerability on your network. At the end of the day, if you have some vulnerability, let's take a look at that for a minute. A vulnerability, right here, is some weakness, some either misconfiguration or a default configuration that could be leveraged by an exploit, and that exploit would be, for example, an individual launching the attack, or it could be a computer system that's the threat launching the attack, which is the exploit. And if it's successful, that it results in risk. Now, companies don't like risk, because risk, if it exists, it could cause the company to go down. If they're attacked and there's a huge amount of risk, the company could be compromised, their networks could be interrupted, data could be stolen, and so forth. The concept here of risk usually equates to money in corporate America today. So how do we manage risk? How do we handle that? Well, first of all, we know that threats are real. That there's going to be individuals doing port scans, ping sweeps, there's going to be software vulnerabilities, there's going to be some network vulnerabilities with their default configurations. So we really can't, say all threats must stop. The threats are going to be there, but what we can do is we can mitigate. See, if the probability of a threat never successfully working, if we can remove the probability of the attack, then we don't have the risk. So it's threat times the probability of it happening and the impact it may have on the business, which results in the risk. That's how I see it as far as breaking it down to its basic components. So what are some of the things that might be vulnerabilities, and what are some of the things that we could do as countermeasures to lessen the risk? I'd like to do that as a quick review of many of the concepts that we've discussed in our Nugget series so far. Let's take a look at this guy right here. On the switch itself, a CAM table overflow attack is very easy to launch, and it leads to eavesdropping, a reconnaissance attack. We can fix that by using something called port security. With port security that we demoed the CAM table flooding, we demoed port security. By using that, we can mitigate that threat of eavesdropping. Another technique on the switch is VLAN hopping. We have a device that wants to negotiate a trunk with our switch. Default configuration says, sure, go ahead. How do we solve that one? With that one, we wanted to go ahead and block all negotiations on our switch ports. That's a configuration error. The default will allow it to happen. We want to lock it down. We also want to tell our switches that we're never going to use VLAN 1, except for the corner cases where you have heterogeneous environments and you've got some multiple spanning tree and you've got other vendors and you might have to allow VLAN 1. But if you don't have that situation, you want to make sure you don't use the default VLAN 1 anywhere. And that will, if you do that and lock down your negotiation, you won't have to worry about the VLAN hopping. Rogue servers. Let's say we have a rogue DHCP device. It wants to be a DHCP server. How do we fix that? If somebody is a DHCP server, that could lead to all kinds of man-in-the-middle attacks, DNS poisoning, etc. So to solve that, we'd use DHCP snooping as a countermeasure. And again, all these things are reducing the probability of that attack actually happening successfully against our network, which is going to reduce the risk. We also have protocol manipulation like spanning tree. Somebody wants to add a switch to the network. They go to their cube, they plug in a switch. They want to become the root of spanning tree. Maybe they connect to 2 switches, which is possible. If you have 2 switches in your wiring closet and CDP is enabled and they're listening, they're going to all the ports and they're finding out what switches are there, they could possibly put a switch in, connect it to 2, become the root, and be a man in the middle. And we solve that by implementing a feature called BPDU guard. What about application layer security? Let's say we poked holes in the firewall with access lists. We're allowing port 25, we're allowing port 80, that traffic is coming in. How do we know that traffic is okay? How do we know the protocols are compliant, that they're not malformed and they're not malicious? As far as malformed, we can have application layer inspection on the zone-based firewall and the ASA saying, you know what, we're going to take a few nanoseconds and make sure that your protocols, your requests, and the commands being used up the application layer are all conforming to the RFCs, and if they're not, we can go ahead and drop it. You might have people out on the internet who are sending in packets and they're spoofing source IP addresses. They're lying about their source IP address. You're either a victim of a Smurf attack where we send, let's say we're from the 23 network, we send it this way, hoping that your network will reply back to the 23 network, which is another network, so you have 2 victims. You have this network as a reflector network, and you have the final destination, the real 23 network, that both get attacked. How can you solve that? Well, you can do authentication as traffic comes in to validate who users are, and to mitigate against somebody lying against your own network. If you had the 23 network here, for example, and they claim to come from 23, you could also do filtering, inbound filtering on the outside interface of the firewall or the outside interface of the router saying, hey, any traffic source from the 23 network can't possibly be good. That network is on the inside. There's no way it can be sourced from the outside. We could also implement the unicast RPF check on the outside of our router. That would also do that for us. It would say 23, the route to 23 is this way, the packet's coming on the outside interface, I'm going to go ahead and drop it. For eavesdropping of traffic, people listening in on traffic, how do we stop that? Well, with eavesdropping, we can encrypt the traffic, either with VPNs flavored as IPsec or SSL. If we're doing IPsec from point A to point B, anybody in the middle who doesn't have the keys won't be able to decrypt and understand that data. If we have people on these switches, they have a PC here and they're lying. What do you mean, Keith, lying? Well, let's talk about lying for a moment. Let me clear this off. Let's talk about lying. Let's say you have these PCs, we'll call it PCA and PCB, and this guy is issuing a MAC off attack, which is the attack we demonstrated for CAM table overflow, and he's sending hundreds of thousands of frames into the network. Each one of them has a bogus and uniquely different source MAC address. Now that right there is a CAM table overflow attack, and this user here, B, let's say he is trying to pretend that he is user C. So he sends a frame in the network, but the source MAC address is actually the source MAC address of computer C. He's lying. So in this case, we could call that spoofing, where you're trying to pretend to be somebody else. And over here with the MAC off, it's not really spoofing because you're not on purpose trying to be a single other device. You're simply randomly generating source MAC addresses. So the difference between a MAC off attack and a spoofing attack is MAC off is generating millions of MAC addresses, not even caring who they really belong to. So to stop layer 2 spoofing, we would use dynamic ARP inspection. And that topic, we discussed it in the switching security lesson. However, for CCNA security, they're saving dynamic ARP inspection and the configuration of it. They're saving that one for your CCNP security. So CCNA security, you're not responsible yet for knowing how to configure dynamic ARP inspection on top of DHCP snooping, but I did want to point out that's a feature. On top of that, if we have DHCP snooping, we can also do something called source guard, which makes sure that these PCs don't lie about their IP address. So if they try to send a packet into the network, if the source IP address doesn't match the DHCP snooping database, they'll drop it. And with dynamic ARP inspection, we're also checking layer 2. If they're lying about their layer 2 address, dynamic ARP inspection will stop them in their tracks right at the switch port. Someone once said, well begun is half done. It may have been Mary Poppins, I don't recall exactly, but that is certainly true in the world of security. If we start our network with the concept of security in mind, we're going to be way far ahead as opposed to building a network and then saying, okay, now it's in, how do we secure it? So having security in mind as it goes in, critical steps, and there's several strategies and life cycles that I've seen and discussed over the years. I'd like to point out a few of them with you. Number one is the security wheel from Cisco. I love this. The security wheel says secure the network. Keith, what do you mean secure the network? We're talking about using access control lists for filtering malicious traffic, intrusion prevention systems, so if you do allow the traffic through on port 80, you can have your firewalls do application layer inspection to make sure the protocols are all solid, and you can have your intrusion prevention system looking for specific known signatures to stop that traffic before it gets to the actual server. So secure the network with all the technical controls that we've discussed in our class, and then you want to monitor the network, maintenance, operations, and occasionally you'd want to test and make sure that it's actually working. I mean, it's no good to say, yeah, we have fault tolerance and it's all in place. Have you ever tried it? And if you and I have never tested our fault tolerance, we really don't know if it's going to work. We're hoping it's going to work, but we really don't know until there's a situation that comes up where it's called for. So we should test it with scheduled downtime before we have some catastrophe happen or some attack occurs. And then when we test it and we figure out that it doesn't quite work, we'd want to improve. That improve also goes for as time marches forward. I guarantee you, we're not using the same firewalls in our corporate networks that we had 15 years ago. They're different. They're stateful filtering now. They have application inspection. I mean, the ASA can do botnet protection as well. It can talk to Cisco's database in the cloud to find out where the attacks are coming from and add protection to it. So there's lots of ability that exists now that didn't exist back then. So we have this process of improving, and then it's a wheel, so it just keeps on going. NIST is an acronym, N-I-S-T. This stands for the National Institute of Standards and Technology, and they came up with a system development life cycle. And that's great. It's about if you want to build a new system, what are the logical steps you'd take? Well, you have the initiation of the project, the development or acquire it, if you either make it or buy it, and then the implementation, the operation, daily ongoing tasks of it, and then at the end of that life cycle for that product or service or whatever it is to get rid of it. And it actually goes clockwise. So that's the 5 steps of NIST's system development life cycle. So you might say, Keith, why does that matter to me? And the key is right here at the initiation of any new system, that's when we need to start thinking about security. Not down here when we're getting ready to implement it, but way at the beginning. If it's a new software application that's being written or purchased, we need to think about the security implications before we ever put our pen to paper and buy that product. Or before the programmers start coding, they need to know what guidelines have to be done in place to make it secure. And it's not just guidelines from us. We might have government standards in certain systems that also have to be complied with. So that's the NIST's system development lifecycle I want to make you aware of as well. Then last but not least, I'd like to take a look at a couple of miscellaneous tools from Cisco that are pretty amazing, and also just touch on a couple of concepts that I don't think I've specifically addressed in our CCNA security nuggets together so far. And the first thing I'd like to talk about is this server right here. This is running your favorite web server, whatever that is. It could be Microsoft, it could be Apache, whatever it is. And let's say that somebody on the internet through port 80 has been sending packets in, and they've been working at it for weeks or months, and they've discovered some vulnerability on this system. And maybe through additional research, they've discovered that it's not just our system, it's everybody who's running that operating system or that version of web services. So the attacker's all excited. The developer doesn't know yet. And so the attacker says, you know what? I'm going to go ahead and leverage this vulnerability as much as I want, and then I will let the world know about it after I've had my time with it. So he spends a few weeks. He leverages some vulnerability for privilege escalation on the box, or stealing information that shouldn't be available to an average web user, and so forth. And then he announces it to the world. Well, guess what? The world, if they get an announcement of some vulnerability affecting that specific operating system, that web server, now everybody's vulnerable. And you have not just one attacker or one team of attackers, you've got any potential user who could launch that type of attack against any of that operating system or that web server. How do you stop something like that? That's a 0-day or a 0-hour attack. You don't have time to really prepare. The answer for that, one of the answers is we could use IPS. IPS inline, it won't know about that malicious attack, but what we could do is we could create a custom signature for it. So an intrusion prevention system, when it's 0-day attack and it's announced before the vendor of the operating system has time to fix their code, what we can do is we can go to Cisco or determine what the attack looks like, use some packet analysis, write a custom signature looking for the telltale signs of that attack, tell our IPS to go ahead and block on it, and then we're going to stop that traffic from reaching our server. So I'm pointing to the switch. I should be pointing to either the router, which is running the IPS services, or a dedicated IPS appliance configured in line between the router and the actual server itself. So that can help with a 0-day attack. The Trojan horse, back from the day, was when they thought it was a gift or something. They brought this huge Trojan horse inside the walls of their fortress, and unfortunately there was a whole bunch of bad guys inside, or the enemy was inside, and they all came out and there was a big battle. So a Trojan for an end user, for a computer user, is something that looks like something else, and they click it and they launch it. Oh, unfortunately, Trojan horses can do a lot of things. They can install viruses. What can a virus do? Like a virus could check for several things. It could infect other things. So Trojans and viruses are considered a blended threat because they could be doing multiple things. How do we protect against a blended threat? Well, there's a couple ideas. One, we could make sure we have virus scanning tools handy and installed and up to date. That's almost a no-brainer. I still remember back in the 80s, I was at Blue Cross of California. The IBM PS2 was recently deployed and available, and it was fun times, the early days. It was fun times. We had a virus, and we had no idea. We had no clue what this was, how to deal with it. We were on the phone with the one single company that was dealing with it at that time. We got rid of it. I thought, my goodness, we need to do something more proactive, which is what managing risk is all about. Defense in depth, planning ahead is all about managing risk early before the attacks show up. So we should have virus scanning software running. It should be up to date, and that's, again, pretty second nature for most computers today. And we also could use something called CSA. That's Cisco's Security Agent, which is the host-based IPS. And you can install that on your critical servers if you wanted to. And the other thing we definitely want is user training. We want to make sure we train our users that they should never open an attachment from an untrusted source. My wife, the other day, true story, she said, Keith, did you send me an email with a link in it? And I did. And the reason she asked me is I don't normally send my wife emails with a link. I thought it would be something she was interested in, so I sent it to her. But before she clicked on that link, she asked me, did you send me this? And that was a good call. I was like, yes, that's awesome. Way to go. So we want to make sure our users also know that they shouldn't be launching stuff or running executables if they don't know where they came from. And we can also use these tools like Cisco Security Agent. We can use virus scanning tools as well to look for that. Now, a couple of products that Cisco has besides the Cisco Security Agent and besides the IPS and the other tools we took a look at, one's called ScanSafe. And ScanSafe is cloud security. Now, if we are a company and all of our software we are running out from the cloud, and so I'll just draw a cloud up here. Woo! So the software isn't on our servers, so a PC here is running software from the cloud. Software as a service. How do we make sure that this client isn't getting bombarded with malicious code? That we're executing it and we're harming the computer and viruses are being installed and everything else. One of the tools is called ScanSafe. And ScanSafe is an acquisition from Cisco, and basically it's for cloud-based services for analyzing the traffic, looking for viruses, looking for worms, and it can help protect against a zero-day attack. I'll tell you why. Because ScanSafe is in the cloud, and if there's a new vulnerability, Cisco can update that ScanSafe virtually immediately and provide you the protection. So if you have IPS in-house and you're worried about the server and there's a vulnerability, you'd have to get the IPS in place, write your custom signature, until Cisco had an updated signature they could create, deploy, and push down. But because everything's in the cloud, a new vulnerability, Cisco sees it, Cisco fixes it, and ScanSafe can deal with it. Another tool is IronPort. And IronPort is a tool that can also help with malicious code. Specifically, it can help against viruses and spam and that are traveling through email. So if all of your email content is screened through an IronPort appliance, it can scan for that and filter that content before it actually reaches your end users. So IronPort I wanted to mention, ScanSafe I wanted to mention, which is integrated into the other products, and they also have one other tool that we have mentioned, and that is CSM. We in class, in the Nugget series that we've done, we've taken a look at CCP, Cisco Configuration Professional, which is, it's good for a handful of routers. You can have communities up to 10 routers each, and you can manage routers through with Cisco Configuration Professional. We also took a look at ASDM, the ASA Security Device Manager, which can manage several ASAs, but it doesn't do them in a group. You can't push out a policy and say, I want this to be applied to the 5 different ASAs all at once. You can manage basically one ASA at a time. In an enterprise environment, Cisco Security Manager allows us to manage our security devices such as IPS appliances, Cisco routers, adaptive security appliances, and so forth in a collective format. So if we want to push out a policy to 10 or 15 different devices and the same policy, we could configure it all on the Cisco Security Manager, apply it, and it could push out the same type of policy to multiple devices simultaneously. So Cisco Security Manager is an enterprise tool that you could purchase from Cisco if you had lots of security devices to manage and wanted to make it convenient to manage them all at once from one pane of glass. In this lesson, we've taken a look at how to reduce our risk. And we do that by putting the appropriate countermeasures. We know what attacks might be coming. We have the appropriate countermeasures in place. And that will, because it reduces the probability of the attack successfully happening, it also is going to reduce the risk. We've also identified some strategies and life cycles, the security wheel and NIST's system development life cycle, and how security should play a huge role at this step, and this one, and this one, and this one. You also may want to jot down those 5 steps of a system development life cycle. That might be helpful for you later as well. And we've taken a look at some miscellaneous tools above and beyond the ones we've already discussed in previous nuggets. Specifically, the Cisco Security Manager, an enterprise-wide tool. We have ScanSafe, a technology for web-based cloud security for looking for viruses and helping to prevent against zero-day attacks. And IronPort to help protect against viruses and spam that we might get via email. I've had a lot of fun in this review. I hope this has been informative for you, and I'd like to thank you for viewing.